Memories last a lifetime, but they're built out of molecules that have very short lifetimes. So how do you get permanence or longevity in a system like that? What I always tell people is find a problem that really fascinates you, immerse yourself, body and soul, in the problem. I think that is the best recipe for scientific success, the best recipe for personal happiness. I was an avid learner, loved math, loved English, loved social studies, loved everything. I wanted to know something about the unknown. I just had a lot of wonder for how the brain would store information. In order for animals to store memories for long periods of time, their brains need access to new proteins. See, even like some of the more distal processes. Exactly. So we did a very simple experiment. We were recording from the hippocampus where the cell bodies are all lined up in a row, and then the dendrites and the axons come down here. So we were recording very far away from the cell body. We expected that when we put a protein synthesis inhibitor on, that the proteins would need to be moved to our synapses. And instead we saw something completely different. We saw there was an immediate requirement for protein synthesis, and that immediate access told us that the protein synthesis source needed to be right there at the synapse. And what these images show us is that the template for protein synthesis, the messenger RNA, is present there. We knew that there were 10 to 20 messenger RNAs. We used new methods to sequence RNA, and we discovered thousands of messenger RNAs. So we're talking about the possibility that every protein that's present at the synapse could be made locally. This represents a new technology for the lab. It allows us to see the organelles that we're interested in particular the ribosomes and the mitochondria, directly in the cell. These little dark spots, those are all ribosomes. For me, seeing things is so convincing. When you actually see the thing that you knew was there by all these indirect methods and it's sitting in front of you, it's really, really satisfying. Memories last a lifetime, but they're built out of molecules that have very short lifetimes. So how do you get permanence or longevity in a system like that? We still have not nailed that. So that's something we need to think about in the next generation of experiments. You know, science is just really fun. It's just enormously satisfying when things work.